Okay, I'm gonna look at some of the examples in the workshop. So here, exercise. We're gonna start with exercise 1, and then at a, so log to the base of 10. Sometimes you will see that, but often not, because we always, the most common base is 10. So when you have log 10, you're gonna be 1. And then let's look at d. So you have d, you have log again to the base of 10 for 0 0 0 0 1. That will give you an answer of -4. And the reason for that, because that is actually the same as 1 over 1,100. So 10,000, because 1 2 3 4. And if you want to imagine this again, if I want to express this, that means the same as 10 to the power of 4. And then this will go up. That means it's going to be 10 to the power of -4. So this is my log. So the base of a log to the power of -4 gives you this value. So this is just another way of expressing exponentials. Let's look at g. So in this case, g got log to the base of 2, and is asking what's the exponential for that. So log 2 to the power of something gives you 8. So that's straight away you will know that it's actually 3, because 2 to the power of 3 means 2 by 2 by 2, and that gives you 8. So the answer for that one is 3. So log 8 to the base of 2 is 3. Let's look at I. In this case, you have log to the base of 2 and 1. So 2 is to the power of something gives you 1. And always when you see that, straight away you should put 0, because 2 to the power of 0 gives you 1. Let's look at L. And that one is, you have a base of 3. And again, it can be any base. Doesn't matter. Could be 10, could be 2, any type. And it's 9. So 3 to the exponential of something gives you 9. And straight away, when you see that, the answer will be 2. Because 3 to the power of 2 means 3 by 3 equals 9. Let's look at slightly different one. Let's look at n. Actually, n is interesting, because log to the base of 3 for 9 equals something. Now let's express 1 over 9 in a different way, because 1 over 9 is actually 9 to the power of -1. Why is to the power -1? Because 1 over 9 actually got exponential of 1, because that's the answer is 9. And if you take the inverse of that, then that will be the answer. So in other words, 3, so 3 to the power of something gives you 1 over 9. Let's assume that's 3 to 9. That means 3 to the power of 2 gives you 9. So that, because 3 by 2 means 3 by 3 gives you 9. Now the inverse to that is minus 2. So in other words, 1 over 3, so 3, and then that of course the same as that, is exactly the same as that. So I could express that in a different way. I could call it 3 to the power of -2. And that's why the answer in this case will be -2. minus 2. Let's look at p. So p says log to the base of e to the power of 3. E is the natural log. So whenever you see log e, we will convert to something called len. So this is a fixed value, 2.71, often used in science and finance, but we have to learn it. So if we want to imagine this question is actually the same, whether it's 10 or whether e, it doesn't matter, the bases are the same. So let's say it's 10, just to try for us to link it, and you say 10 to the power of 3 equals something. That means 10 to the power of something gives you this value. That means it's 3, because 10 to the power of 3 is actually 10 to the power of 3. So that means if you use the same thing here, so the answer for that one should be the same way. So 3, so e to the power of 3, e to the power of 3 gives you that. Let's look at q, and q says len e to the power minus 1, and it's asking you what is the value for that. And again, whenever you see len, that means log to the base of e is the same as len. So always remember, this is how we express natural logs. Then that means e to the power of something gives you, this is actually straightforward as well, because that should be minus 1. But just in case, if you want imagine it, you just imagine there is an e to minus 1 gives you e to the power minus 1. Let's look at r, and this one says len 1, and always remember there's an e value here, gives you to the power of something gives you 1. And they always remember, whenever you get something like that, the answer is always 0, because whatever e to the power of 0 gives you 1, 10 to the power of 0 gives you 1, 7 to the power of 0 gives you 1, and so on. Always the answer for these questions is going to be 1. Size 2, and here we look at the rules of logs. So the a here, log a3, and then the first rule, or in logs, that actually can be expressed in the form as 3 log a. So this is another way of expressing logs. b, you have log a multiplied by b, and you can imagine there is a bracket here, so log comes on the first one, goes on the second one, and this should change to a positive sign. So the answer for that one will be log a, and then you express the first one plus log b. That's the first thing you need to learn in terms of the rules of logs. The c here, in this case, is going to be the division rule. So in this case, you have log a divided by b, and then you get a bracket here. It just helps you to make the distribution, and this is going to be log a minus, I'm going to change this division into a minus like this, log b. Let's look at d. So you have log, and then got a bracket again, so a to the squared multiplied by b. You may get the brackets, you may not be, so it's exactly the same. So log a squared b, that's actually the same thing. So you need to know that actually is exactly the same thing, because that helps you to simplify it. So again the same thing, if you put a bracket, it just helps you. It's just going to help you just to get it correctly. So you can get log, so you get the 2 log a here. This is multiplication, that means I get a positive sign, plus log b. Let's look at g. So g here it says log a5 divided by a2. Put a bracket, it just helps you. Then you get the first one, then the second one, and the middle is the division. So, and then I will simplify it in the same time. 5 log a minus 2 log log a. So the division is the difference between them. That means, because these are the same, that means I will end up with 3 log a. Let's look at h, and in this case you have log b3 divided by b. Then exactly the same thing again, put a bracket, log b, you got 3 here, then go put the division, log b, and these are the same. That means the answer is 2 log b. Now we finish with exercise 2. Let's look at exercise 3, and in this case you have, so exercise 3, and here more examples. Let's look at the first one. So a log 12. So the rules you learned before will help you to simplify numbers, because log 12, it comes from 4 multiplied by 3, and then put the brackets. That means log 4 plus log 3, and then log 4, in this case you got everything in the base 2, so log 4 is going to be 2 plus log 2 to the base 2 of 3. Now let's look at b. So b says log 20. So because there is nothing being indicated here, that means it's a log with the base 10. I can simplify this further by saying this comes from log 10 by 2, because that's the same as 20. That means log 10, this is going to be positive, plus log 2. This one, 10 to the power of something gives you 10. So 10 to the power of 1, that means 1 plus log 2. That would be your answer. Let's look at C. So C says len, which is again the natural log, 3e. And here again this is multiplication. So in order to make it easier for that, put the brackets and then do the rule we said before. That means len 3, multiplication should be plus len e, and whenever you get len e, we said that because this e is to the power of something gives you e, that means must be 1. That means the answer for that one is len 3 plus 1. That's the answer. Let's look at D. D says log to the base of 3 to 27. Then this is easy questions, because 3 to the power of 3 gives you 27, because that's 3 to the power of 3. 3 by 3 by 3 gives you 27. Look at E. Log 3 log to the base of 3 to 18. That means I want to simplify that, because there is nothing e to the power of x, it won't give you 18. So we'll have to simplify it. And the way you simplify, you're going to come with something which can we can be simplified easier, so further. So something like log to the base of 3, this comes from 9 by 2. So that will make it easier, because you're going to say log to the base of 3 of 9 plus log to the base of 3 of 2. 3 to the power of something gives you 9. That means 2 plus log to the base of 3 to 2. So that's going to be the simplest form you can achieve. Let's look at f. So f here says log 200. Log 200, then that means you can't. 10 to the power of something gives you 200. Let's try that. 10 to the power of 1 is 10. 10 to the power of 2 gives you 100. 10 to the power of 3 gives you 1000. Then that means 200 is not something, it's not an option, it's something in between. So the only way to get a simpler value of that is actually through simplifying it further. So log 200 comes from 2 multiplied by 100. That means log 2 plus log 100, right, is the same stuff, same thing. So log 2 plus log 100, 10 to the power of 2, something gives you 100, that means 2. So that's the simplest form. Let's look at question exercise 4, just further examples. So exercise 4, and then we go through some of the questions. Exercise 4, and then here more about natural logs. So ln a minus 3 ln 1 minus a. Ln a minus 1 minus 3 ln 1 minus a. Whenever you see something like that, it's actually, this is a simplified form. So you want to revert it back. You see minus, that means a division. And you get the lens on both sides. That means I have ln here, a large ln, I have a division. That's what I have. So that means the first part will be a, because it's the because of the division. Also you got because just the original form where you simplified it and you end up with this form. So 1 minus a, let's remember the rule we said before. This should come here. So 1 minus a to the power of 3. So that's the answer for a. Let's look at b. It says ln sine x, and then the whole thing is squared, minus ln sine x. Now again, you got the minus, that means I have a division, and I got the lens on both sides, that means I get large ln here, sine x here, just keep things the same, squared sine x, and then that means the whole thing goes with that. That means the answer is ln sine x. Let's look at c. 4 ln c minus half ln d. Now the same thing, you got minus, that means I have a division. I got the ln on both sides, large ln. Then that means, remember the rule we said, this should come here. So c4, this should come here. That means d to the power of half, which means is the square root of d, which is the answer. So that is the answer. Okay, question 8. So it's about pH. pH equals the minus log the hydrogen ions concentration, and it's telling you it's equals to 9. So the value is 9 minus log hydrogen ions, and that means, you remember this is a base of 10. That means 10 to the power of 9 10 to the power of 9 gives you the hydrogens. So hydrogens means the concentration will be 10 to the power of 9, but don't forget the negative sign. This is the concentration. Look at the constant Kw, hydrogen ions and the hydroxyl ions multiplied, that will give you minus 10 to the power of minus 14. So that is together minus 14. You already found that one, which is 10 to the power of minus 9 multiplied by OH minus. That means the hydroxyl ions will be 10 to the power of minus 14 divided by 10 to the power of minus 9. And the division of that, the result of this division will be 10 to the power of minus 5. And that will be the answer. Let's look at the next question. Question 9. And that is looking at straight line equations. And for that one, you have the equation here, y equals a e, and that is to the power of ax squared. Let's recall the equation for straight line. So when you have a straight line, you always have this form: y, the y-axis, and here you have m, a constant, mx, that refers to the x value, plus c. So y, that's on the y-axis, this is my x-axis, and then this is the gradient, and this is the intercept. So they're always constant values, and then of course they change according to the x and y. Now let's apply that equation, the straight line equation, to this. We can't do it in the current format because it needs to be similar to this format, and the only way you can do this is you simplify the e, because that is a natural log. So if I take ln y for that equation, ln y equals ln a, and let's remember the rules of logs. When you have multiplication, in this case, we will have a positive, we will have addition. That means minus ax squared. And let's arrange the equation: ln y minus ax squared plus ln a. That will fit perfectly with the straight line equation. That means this is my y-axis, this is my x, this is my gradient, and this is my intercept. So this that will be the answer for this question. Let's look at the final and the last question, question 10. And in this case, the question is asking you for the value of k. So you have this equation, delta G equals minus RT ln k. And of course, if you want to take k equals delta G over minus RT, and then you want to get rid of the ln, that means k equals, because it's of a base of E, delta G over minus RT, and that will be the answer. So question 10 part A. Let's look at B. So we'll still question 10 part B, and it says here, if I have delta G equals delta H minus T delta S, then I should be able to replace that part and just put it here. And that's what we could do. You say K equals E and then just replace it. So don't forget the negative sign. That means minus delta H minus T delta S, and then here you have the RT. So put bracket here so you always don't forget the sign. That means T delta S, and here it's going to be minus delta H over RT. That would be the K value. The final question, it says you have K1 and then K2 and then T1 and T2. So clearly here you have a difference, and the difference is we can describe it in the form of k1 to k2. And then we simply is exactly the same as this equation. So what we can do, we can just use the same thing, T1 delta S, and of course this we got E minus delta H over RT1, and then it will be E T2 delta S minus delta H over RT2. So that's going to be the form for the equation. Now if I want to simplify this, whenever you see this, that means then it's a natural log. So ln k1 over k2, that means I can get rid of the e, so that means t1 delta s minus delta h over rt1, and then when you have a division, that will be minus. Let's remember the rules of logs. So that means t2 delta s minus delta h over rt2. Now that means we brought everything the same level, but still we need to simplify it further. The way we can simplify this further, we can, if you do a normal way, you can't, because these are different. You can't just do it a normal way. So what we can do, we can separate the top terms. So this one over RT1 minus delta H over RT1, that should be fine. T2 delta S over RT2, and here you need to be careful because you got a negative going into negative, so that will change, so it will be positive, so be careful with that part. Delta H over RT2. Now this allowed us to get rid of some parts. So here you can get rid of this, and you can also get rid of that part. Now let's see what happened now. So we got delta S over R minus delta H over RT1 minus delta S over R plus delta H over RT2. Now we can also get rid of some parts here. So if you look, those they can cancel each other. So this goes with that, and then we can simplify further. That means you have minus delta H over RT1 plus delta H over RT2, and then you could take a common factor here. So you could take the delta H over R, the common factor. So you could just change the way, so it becomes 1 over T2 minus 1 over T1, and that will give you the answer for ln K1 over K2. So this is the final answer.